In this video, we're going to talk about one of the most important ideas in mathematics, and that's whether order matters when you multiply two numbers. So, for example, is 3 times 4 the same thing as 4 times 3? Are these two things equal to each other? And regardless of whether these two are equal to each other, is it always the case that if I have some number times some other number, if I swap the order, am I going to get an equivalent number? Well, pause this video and see if you can work through that. Try to think about that a little bit before we think through it together. Well, let's think through this particular example, and we're going to do so with the help of some angry cats. So we clearly see some angry cats here. Meow. Yes, they are angry. We could view this as 3 groups of 4. So this is one group right over here of angry cats, 4 angry cats. This is 2 groups of 4 angry cats. And this is 3 groups of 4 angry cats. If we view the first number here as groups of the second number, but we could also view it as 4 groups of 3. How would we do that? Well, we could have one group of 3 angry cats. We can have 2 groups of 3 angry cats. We can have 3 groups of 3 angry cats. And we can, of course, have 4 groups of 3 angry cats. So based on that, if you think of it, the first number as groups of the second number, well, it seems like the order doesn't matter. Another way you could think about it is, here you have 4 rows of 3 angry cats. You have 1, 2, 3, 4 rows of 1, 2, 3 angry cats. And so to figure out how many total cats you have, you multiply 4 times 3. But you could view this same group of angry cats, but just view it with a slightly different perspective. So here we have our angry cats. And then let me rotate our angry cats, probably risking making them a little bit angrier. Let me move them back in. And now we could view this as 3 rows, 1, 2, 3, of 4 cats in each row. So let me put all of these upright. So we have 1, 2, 3 rows of 1, 2, 3, 4 cats. Don't want to look at those because it might make us a little bit confused. And we're dealing with the exact same number of cats. And so I'm only dealing with 3 and 4 here, but what you will see is order doesn't matter when you are multiplying two numbers. And we could also see that on a number line, and we could do that with multiple examples. I'll keep a couple of angry cats here looking at us just to keep us in check. If we want to think about 3 times 4, we could view it as 4 threes. So 3, 6, 9, 12. Or we could view it as 3 fours. 4, 8, and 12. And I've focused a lot on 3 and 4, but we could do it with any two numbers that we're trying to multiply together. So let's say we wanted to do that with, I don't know, let's see 6, whether 6 times 4, whether it's the same thing as 4 times 6. Well, you could view it as 6 fours, 4, 8, 12, 16, 20, and then 24. Or you could view it as 4 sixes, 1 6, 12, 18, and 24. So big takeaway, order doesn't matter when you are multiplying numbers like this. And this is sometimes referred to as the commutative property. It's a fancy word, but it's really just saying that whether you're doing 6 times 4 or 4 times 6, the commutative property of multiplication says, hey, those two things are going to be equivalent. Meow. Yes, they are angry for being rotated.